Question number 26 of GATE 2018 Civil Engineering pronunciation is discussed here. A prismatic beam PQR of flexural rigidity, that is EI equals to 1 into 10 to the power 4 kilonewton meter square, is subjected to a moment of 180 kilonewton meter at Q as shown in the figure. So the rotation at Q is, that is 2 into radian up to 2 decimal places, is to be calculated. So student has to again recall the concept of fixed moments. He has to solve this problem properly, understand the concept of prismatic beam. So fixed moment is equals to FQP, or QP equals to 0 or QR equals to 0. Now if we just see slope deflection equation for span QP and QR, so for both the span QP and QR is to be calculated. So slope deflection equation, if we just consider for the first one, that is QP, this is for QP. So MQP, that is equals to MQP plus twice EI by L multiplied by theta P plus twice theta Q minus thrice delta by L is the formula for slope deflection equation. So as you know, MQP, moment QP, is equals to 0, since we have to calculate fixed moment. Now here twice EI by L, EI is already given, L, length of this span, is also given. Theta P and theta Q, theta P is 0 at point P, and again delta is also 0. So finally we'll get this slope deflection equation for span QP in terms of theta Q, and that is equals to 8000 theta Q. Similarly, we have to calculate slope deflection equation for QR, span QR. So same slope deflection equation, MQR, that fixed moment, that is equals to MQR plus twice EI by L multiplied by theta R plus twice theta Q minus thrice delta by L. Again this theta R and delta equals to 0, and we will get again MQR, that is the fixed moment for QR, that will be equals to, in terms of theta Q, theta Q. So now we have to take the moment about the Q, and so summation MQ, that is equals to 0, that we know that MQP plus MQR minus 180 is equals to 0, and we already calculated MQP plus MQR in terms of theta Q. So we have to just put the value 8000 theta Q plus 10,000 theta Q and minus 180, since the moment is acting at point Q. So here we will get in terms of theta Q, and finally we can calculate theta Q as 180 divided by 18,000, and this is equals to 0.01 radian. This is what we want. We want the final answer in terms of 2 decimal point and in radian. So this will be the final answer, 0.01 radian. So what we have done, we have just calculated the fixed moment for the slope deflection equation. We have just considered there for two span QP and QR, and accordingly we have just find out the theta Q which is required, in terms of radian. That's to up to 2 decimal points. Now here students has to properly recall the equation of slope deflection. He has to take the proper moment at moment about q, which is equals to 0, and once he put this value for span qp and qr, he'll get the value of theta q. So this is how the student has to solve the problem related to slope deflection equation.